how to convert fractional basis to decimal. What we just finished now in the last video was whole numbers, right? But now we have decimal point in between the numbers. The same procedure, but a little different. How does it work? Let's see. Solution. The first question is 1 is 0, 1 is 0, 0.011 is these two. Now, this is the first question. The whole number, this is the whole number, and this is the decimal part, right? So the whole number, you number it the way you did before, which is 0, 1, 2, 3. But number after is what? Negative, just like your number line system. Number line system, this is 0, this is negative, this is positive. Right? So you have count this. Now the next to count is the negative part. So this is what? Negative. This is their turning point, right? So this is negative 1, negative 2, negative 3, negative 4, 5, 6, and so on. Okay? So please take note. This is very important. This is derived from the number line for the whole number and for the decimal number. So this is the whole number, right? And this is decimal point. So you start from their turning point. You start 0, up, negative. Please take very good note of this. It's very important. And it's what we did from our previous videos. Now, let's begin. The first number is 1 times 2 power of 3. The procedure, the next procedure is the same. Next, 0 times 2 power of 2 plus 1 times 2 power of 1 plus 0 times 2 power of 0. This one is finished. Plus, continue. 0 times 2 power of negative 1 plus the next. It's not continued, so I want to continue here. 1 times 2 power of minus 2 plus 1 times 2 power of minus 3. This is continuing. Okay, now what do we have? Expand it. 2 to the power of 3 times 1 is what? 8, right? 8. Plus 2 to the power of 2 is 4 times is 0. This is 0. Plus 2 to the power of 1 is 2 times 1 is 2. So we have 2. Next, any to the power of 0 is 1. 1 times 0 is 0. Next, now this is law of indices. Remember the law that says a to the power of minus x, it becomes 1 over ax, right? If you miss it, well, check it out. Mathematics is validation. So, this is 0, so everything here is 0, obviously. But this one will not be 0, because this is 1. So, this is 1 times, we write this guy as 1, 2 to the power of 2, right? Plus 1 times 2 to the power of 3. This guy is 4, and this is 8, right? So, let's continue. 8 plus 0 plus 2 plus 0 plus 0, and this gives us 10. Plus, this is 1 out of 4. This is 1 out of 8. Of course, you know that 2 in 3 places is 8, right? So this is 10 plus 1. You can use calculator now. 1 divided by 4 will give us what? 0.25. 1 divided by 8 will give us 0.125. Sum everything together. This is 10, 3, 7. So we have 10.3 3755 in base 10, which means the equivalent of this in base 2 is same as this in base 10. The procedure is the same. Only difference is this guy, the number. Once you miss this guy, anything you do here is fallacy, wasting of time. Okay, so be careful. So let's quickly go to the second question. Now we have 362.35 in base 8. Start numbering. For the point, first, number the whole number. We have 0, 1, 2. Now, number the decimal part. -1, -2. So, as usual, pick one after the other. The first one is 3 times base power of 2. Second one is 6 times base power of 1. Third one is 2 times 8 power of 0. The next one is 3 times 8 power of -1. And the last is 5 times 8 power of -2. So quickly, 8 squared, that is 8 in 2 places, that will give us 64. 64 times 3, that will give us 192. Plus 8 in 1 place is 8. 8 times 6 will give us 48. Power of 0 is 1. 1 times 2 is 2. Plus, now this is 3 times inverse of this. That will be 3/8. And this is 5 times inverse of this. That should be 5. 8 squared. Right? 8 squared, which is 64. Now, add the odd number parts. Divide this guy the way we do here. Divide this guy by 63. Sum everything together. So, try that. Okay, let me write this. This is 192 plus 48 plus 2 plus 3 divided by 8 will give us 0.375. 5 divided by 64 give us 0.078125. Sum them together. We have 242 points 453125. Of course, you can approximate it to 2 decimal places. Good. The next question is converting hexadecimal to decimal. Hexa, base 16. 428.12 in base 16, as usual. From the point 0, 1, 2. After the point, negative, negative. Finish. Now, pick it one after the other. We have 4 times 16 power of 2 plus 2 times 16 power of 1 plus a times 16 power of 0 plus 1 times 16 power of -1 plus 2 times 16 power of -2. So quickly expand it. A is what? Is 10. So we have 4 times 16 in 2 places plus 2 times 16 plus 10 times 16 power of 0 plus 1 over 16 plus 2 over 16 squared. Right? So without wasting much of our time, 16 squared times 2 will give us 1024 plus 2 times 16 is 32. 60 power of 0 is 1. 1 times 10 is 10. 1 divided by 16, that is 0.0625. Use your calculator to confirm it. 2 divided by 60 squared will give us 0.0078125. Use your calculator to confirm it. Sum everything together. We're going to end up with 1066.070 3125 in base 10. So this is 428.12 in base 16. It's easy. The last question, quickly. 32.06 in base 7. In base 7. This other base now, right? I think you can play. You can see that all the number here, they are not up to 7. All the number here is not to 60. All the number here is not up to 2. All the number here is not up to 8. Because it's the base. So, number is first. Before the point, 0, 1. After the point, negative, negative. Right? That's not really good. So, now let's start. 13.71. 2 times 7, 0. 0 times 7 minus 1. And lastly, 6 times 7 minus 2. Okay? 7 power of 1, 7. 7 times 3 is 21. Any power of 0 is 1. 1 times 2 is 2. This is 0. So obviously this will be 0. And this is 6 divided by 7 squared. That is 6 divided by 49. So this one will be 23 plus 0.0204. You can use calculator to check it. Add it together, we have 23.020 in base 10 from base 7. And this is finished. Now, so far, we have seen how to move from other bases to base 10. Now I want to see how to move back using what we have done before. When we are moving forward, we are multiplying. So we are moving backward, we do what? We divide. Right? We divide. Let's see how. Good. So we have seen how to convert from other bases to base 10. Now let's see how to move from base 10 back to the other bases. This is what we want to do. Now, let's look at the first example. Convert 26 in base 10 into binary. Binary means what? Base 2, right? Binary means base 2. So, when we are going from base 2 to base 10, we multiply. So, when we are going from base 10, base 2 back to base 10, we do what? We divide. And to divide, what do? We have our number. This is 26, the number given. The base is 2. So this is the number in base 10 and this is the base 2. So we want to check how many times 2 goes in all these numbers. You know, very relate to what we have done before. So let's go. 2 goes here, 1, 2 goes here, 3. What is remaining is what? Is 0. Nothing remaining. Right? Again, 2. We have to use 2 throughout because it's in base 2. If it's base 8, we use 8 throughout. Base 16, we use 16 throughout. Base 100, we use 100 throughout. Okay? So how many times 2 goes in 1? Not possible. How many times 2 goes in 13? That will be 6. Remaining what? 1. Because 2 times 6 is 12. And 12 plus 1 will give us 3. Are we together? Again, 2. 2 goes in 6. It's 3 times. What remain? Nothing remain. Because 2 times 3 is 6. 6 plus 0 is 6. Again, 2. 2 goes in 3. 1. What is left is 1 times. So 2 times 1 is 2. And 2 plus 1 is 3. So anything you divide, you can check again. Can 2 goes here? 2 goes here. 0 times what is left is 1. It is finished. So what do? You read from down upward. You read from down upward. So which means 26 in base 10 is the same as what? 1, 1, 0, 0, 1, 1, 0, 1, and 0. In base what? In base 2. Be careful, the base must be subscript. Don't go and write something like this 1, 1, 0, 1, 1, 2. It's wrong. This is wrong. Okay? Don't write this. But you write this. Very easy, right? The same method, the same procedure for others. So let's go to the next one. We have 1, 4, 5, 7 in base 8. Now we start. How many times? How many times 8 goes in 1? It's not possible. How many times 8 goes in 14? It's only once, right? It's only once. So, how many? What's the remaining? That will be 8, 12, 4. 4. So, how many times 8 goes in 40? 8, 14 is 6. It's 6. So how many times 8 goes in 65? 8 goes in 65. In 64 is 8 times. So remaining 1. How many times 8 goes in 17? That is 2. What is left? What is left? Remainder. How means remainder? Remainder 1. You can cross check. Multiply this guy by this guy plus this guy. It must give us this guy. If it doesn't give us, there is a problem. Somewhere. Again, 8. 8 goes in 1, not possible. 8 goes in 18 is 2. Remaining 2. So 8 goes in 22. Also 2. Right? Remaining 6. Remaining 6. So you can check it now. You can check it. 8 times 22 plus 6. You must get this. If we not get this, there's a problem. Again, 8. We have to use 8 all through because it's 8 up. So how many times 8 goes in 22? It's 2. What is left? 6. 6. Again, 8. Can 8 goes in 2? It's not possible. So it has reached. What is left is what? 2. You multiply it. 8 times 0 is 0. 0 plus 2 is 2. So this guy plus this guy must produce this guy. So anytime you multiply and you divide, make sure you check to be sure that everything is okay. So finally, we can write out our result. Don't forget to write down, up, bottom, up. So that is 1, 4, 5, 7 in base 10 is equivalent to 2, 6, 6, 1 in base 8. We can also convert this back using our formula. The last video. Very easy, right? If you don't write this, it is not finished. Because this one, somebody can read from up down. It is wrong. You have to read from down up. Let's go to hexadecimal. For the hexadecimal, it means it's 16, right? It's 16. Now, again, can 16 goes in 9? Is that possible? Can 16 goes in 94? Yes. How many times? 5 times. And then the limit is 9 times. So 16 goes in 948 in 59 times. What is left is what? 4. Again, can multiply this guy by this guy plus this guy, you must get this guy. 16. How many times 16 goes in 59? 3 times. What is remaining? It's 11. Can you write 11 down? No. What is 11 in hexadecimal? Numbers finish by 9. 10 is A. 11 is what? 12. So this guy is B. You cannot write 11. If you write 11, it will read as 2 numbers. Again, 16. Can 16 goes? Not possible. It has reached the destination. So, remaining 3. Now, reach bottom up. Bottom up. You can say 948 in base 16 is equivalent to what? 3 B 4 in base. This is base 10 and this is base 16. Finito. Finito Italiano. That is Italian language. The last question. 94. How many times? 9. 3 goes in 9 is 3. Nothing left. 3 goes in 4 is 1. What's remaining is 1. 3 again. 3 in 3 is 1. 3 in 1 is 0. What is left is 1. Again, 3. 3 in 10, 3. What is left is 1. Wow, 1. Write everything 1. Okay. 3 goes in 3. Yes, 1 times. What is left? Nothing. 3 goes in 1 is not possible. What is left is 1. So it has finished. So it means that 94 in base 10 is, so read bottom up is 1 0 1 1 1 in base. Now let's see how to work with the fraction. Good. Now we have seen how to convert whole number to decimal, fractional to decimal, from decimal to whole. Now I want to see how to convert from decimal to fractional And here we have the first question. So conversion of fractional bases to other bases. This is fraction in base 10 to other base, now base 2. Now we have 2 parts. We have the whole number part and we have the decimal point part. For the whole number part, it's very easy. We rule a line, right? Just like what you did before. But for the fractional parts, it is not the same. Let's see, let's break it down. Solution. The first part is 25, which is whole number. So this one, we do it our normal way. 25, binary is 2. What do? We divide as usual. 2 goes here, 1. 2 goes here, 2. Left, 1. That's like what we did before. 2 again. 6 left, 0. 2 again, 3 left is 0. Okay. 2 again, 1 remaining, 1. 2 again, 0 remaining, 1. So we read down, up. For 25, we have, for 25, we have 11001 for this part. Now, for this part, the decimal part, don't forget this one is finished. So we can say it's 0.375. Now, what do we do here? This place, to reduce, we are dividing by 2. But this place, to reduce, we multiply by 2. If it's base 8, we multiply by 8. If it's base 16, we multiply by 16. Do you see the difference? We divide the 4 whole number and multiply. So what do we do? Multiply by the base. Let's go. This and this is 0. 1 is left. This and this, 14 plus 1, 15. 1 is left. This times this, 6 plus 1, 7. This times this is 0. Nothing remains. If nothing is remaining, what do? Is 0 here? We write it out. Is 0. Write out is still the same thing as left. So again, multiply by 2. Our aim of this one, we divide until we get 0, right? Our aim here is multiply until we get 0. Are we together? You divide until you get to the least number, the least whole number. And this place, you divide until you get to the least fraction number. Whole number. Again, let's go. Multiply. This and this, 0. This and this is 0. Left 1. This times this, 14 plus 1 plus 1, 15. Left is 1. This and this is 0. Plus that 1 is 1. That one that is left, write it out. So the remainder is here. The remainder is here. The remainder of here is what? 1. After decimal. Anything that comes after decimal is what we write out. So if you write it out, what is left here now is what? Is 0. Because we have taken 1 out. So we have 5 is 0 is 0. Because we have taken 1 out. But after decimal, it must be 0. Because we have finished it. Anything that comes after decimal is what? Return it to 0. So if this one go outside, what is left is 0. Again, times 2, because we have not got 0. Multiply, this and this is 0. This and this is 0. This and this 10. I write 0. Remaining 1. 2 times 0 is 0. Plus 1, 1. If I write the remainder out, this one will go out. What is left is what? Is 0.000. And that is finished. That is finished. Now, be careful. This place, we read from the least up. But this place, we read from up down. Are we together? Mathematics is very sweet. You move this way and you come down this way. So for this part, put everything together. 25.375 in base 10 is now the same as this one is what? 11001 points 0 1 1. Base 2. Are we together? Very, very nice. Very, very nice. Whole number, you divide until 0. Fraction number, you multiply by the base until you get no number. Right from up, down, and this one is from down, down, up, up, down. More example. The same procedure. The same procedure. The first part is whole number, which is in base 8. Good. So again, take the whole number out. What do we have? This times 8 divided by 62. 64 is 7, right? 7. Remaining 6. Again, 8 5 let's go here, 0. It's finished. Remaining 7. So it's finished here. For this one, it's finished here. I read down, up. For this part, this guy is 0. So I have 0.0625 times what base? 8. Interesting. Now let's multiply. 8 times 5, 40. Is 0. We keep 4. 8 times 2, 16 plus 4, 20. We keep 2 now. 8 times 6. 8 times 6 is what? 45. 45. Is it 45? No. 8 times 6. Now 8 times 6. No, it made it 2 before. 8 times 6 is 48 plus 2, 50. You write 5, we keep 5. You write 0, we keep 5. 8 times 0 is 0. Plus 5. 5. And 8 times 0 is what? Is 0. So what is left after the point here is what? Is 0. Again, times 8. 8 times 0 is 0. 0. 0. 40. We write 4, and 0, we keep 4. 8 times 0 is 0, plus 4 is 4. What is remaining here is what? 4. So if 4 is out, what is left? Is 0, 0, 0, 0, 0, which is finished. This down, up, this up, down. So, which means 62.0625 in base 8 is equivalent to 76.04 in base 8. See, the gap I finish it. I've calculated it, I estimate it. That's an assumption. Mathematics is very sweet. The last question, hexadecimal. 16. Again, take this part out. 290 by 16. So how many times 290 goes in 16? Obviously 8. What is left? 2. 16 times 8 plus 2 will give us this. Again, 16. How many times? 1. Left? 2. Again, 16. How many times? 0. Finish. Remaining 1. So this down, up. Now, this part. This is called 0.875 times 16. Multiply 16 by this guy. We're going to get 0, 0, 0, 14. You get this. So if 14 is out, what's left here is what? 0, 0, 0, 0. So this was very fast. But can we write 14? No. What is 14 in hexadecimal? 10 is A. 11 B. 12 C. 13 D. 14 E. 14 is E. And since it's only one number, you write the only number. So which means 290.875 in base 10 is equivalent to 122 points E in base.